All right, so today we're starting chapter 5, and chapter 5 is on indices, surds, and logarithms. Let's get into it. So the first thing we're going to look at are we're going to start off with indices. And the first thing I want to point out is that if you have a situation where you have a number raised to a power, the number is called the base, and the superscript number is called the power or index or exponent. And of course, indices is the plural of index. So if you're going to do indices, one of the first things you need to be aware of are the laws of indices. You started looking at those from CSEC. So these are like the 7 laws of indices. And in one, essentially one is saying, if you're multiplying and the base is the same, you must add the indices. So you have a raised to the power n, m multiplied by a raised to the power n. A is the base, m and n are the indices. So if you're multiplying and the base is the same, you should add the indices. Now a to the m over a to the n is the same as saying a to the m divided by a to the n. And essentially this law is saying if you're dividing and the base is the same, you should subtract the indices. If you're dividing and the base is the same, you should subtract the indices. Law number 4, a to the 0 is equal to 1. A to the 0 is equal to 1. So essentially this is saying any number or any base raised to the power 0 is equal to 1. Law 5, a to the m in bracket raised to an external power n is equal to a to the m multiplied by n. In other words, the power inside the bracket is multiplied by the power inside the bracket. Law number 6, fractional index, a raised to the 1 over m. M being the denominator is the same as saying the m root of a. So whenever you have a base raised to a fractional index, the numerator is the power and the denominator is the root. So that brings us to 7. And 7, again, we have a fractional index. A is raised to the power m over n. So that is the same as saying, remember I said earlier, if a number is raised to a fractional index, the numerator is the power and the denominator is the root. The numerator is the power and the denominator is the root. So if you look carefully at 7, that are showing you different ways to express the 7th law of indices. All right, so while going through the list of laws, we didn't really mention the negative index. So that's law 3. So if a base is raised to a negative index, the power of the power of the index can be changed by changing the position of the base. So when I said it, the sign of the power can be changed by changing the position of the base. So for example, if it's in the numerator and the power is negative, you can move the base to the denominator and the power becomes positive. if the base is raised to a negative power in the denominator, you can move the base to the numerator and the power becomes positive. All right, so that is something to note. All right, let's have a go at example 1. This is example 1. Please have a go at example 1. And let me give you a couple of minutes to attempt it, and then afterwards I will come back and do the questions. All right, so again, example A is asking us to simplify A, x to the 1/5 multiplied by x to the 3/5. According to the first law of indices, if we're multiplying and the base is the same, we should add the indices. So essentially this would be x to the 1/5 plus 3/5, which is the same as saying x to the 4/5. If you're multiplying and the base is the same, you must add the indices. Same thing with B. We're multiplying, the base A is the same, so we must add the indices. So we have A to the 5/6 plus minus 1/3. This is the same as saying A to the 5/6. A positive times a negative is a negative. And 1/3 is the same as saying 2/6. So this would be A to the 3/6, which is the same as saying A to the half power. See, we're multiplying and dividing. So this is going to be equal to y to the minus 2/5 plus 2 minus 3/10. All right, so the subtraction is because whenever you're dividing and the base is the same, you must subtract the indices. So we're subtracting minus 3/10, so it's minus 3/10, which works out to be positive 3/10. So this is y to the minus 2/5 plus, let's convert the 2/5 to 4/10. So 2/5 is the same as saying 4/10, plus 2, which is same as saying 20/10, plus 3/10. So 20 plus 3 is 23 minus 4. So your final answer is y to the 19/10. So D now, the power inside the bracket, we're using that law. The power inside the bracket is multiplied by the power outside the bracket. So 27 is the same as saying 3 cubed times 1/3 x cubed times 1/3 and y to the 6 times 1/3. So our final answer would be 3 to the 1, the power 1, x to the power 1, which is just x, and y squared. So if the power is 1, you don't need to put it. Your final answer is 3 to the power 1, which is 3, x to the power 1, which is x, and y squared.